Okay, so not able to hear you people clearly, but this is your theorem. What does it say? Every composite number can be expressed or factorized as a product of primes.
Sir,
Yes, tell me.
green is not said, sir.
That's what Charan was also trying to say, right? Not able to hear. Can you see the screen now, guys?
Yes,
Yes,
sir.
sir.
So we are working with fundamental theorem of arithmetics. So what does it say? It says that every composite number can be expressed, which means factorized, as a product of primes. And this factorization is unique, apart from the order in which the prime factor occurs. So let's try to understand this, okay? All of you know what's a composite number, right? Give me some example of a composite number, small one, not a very big one. Give me some number.
4.
Yes, 4 is a composite number. Let's take a bigger one. Let's say, let's write 12. Okay. 12 is a composite number. When you do a prime factorization of 12, what do you get? 6 are, 2 3s are, 3 1s are. That means you can write 12 as 2 into 2 into 3. Everyone agrees with that? Everyone knows this is a very easy thing which you have studied earlier also. So this is what they are telling. You already know this, but you are learning it in words now. That every composite number, you can express it in terms of product of some prime numbers. Okay? This is basically 2 square into 3. There is one more thing they are telling, that this factorization is unique. What does it mean? It means this factorization belongs to 12 only. This cannot be a factorization of any other number. Neither 12 has any other factorization. This is unique. 12 cannot be factorized in any other way. Can you factorize 12 in any other way? Someone may say, okay, I will write 3 into 2 into 2. So changing the order, that's not a different thing. That is ignored over here. That's what they're saying, apart from the order. If you want, you can change the order, but other than that, no other way to write the factorization of 12. So this is unique. Everyone understands that, what I'm saying here? Fundamental theorem
Yes.
of arithmetics.
Yes, sir.
And you should know that every composite number you can think of that can always be represented in as a product of some prime numbers. Every composite number can be represented as product of prime numbers, and that representation, or that whatever you have written factorization, it is unique to this number apart from the order. Okay. So this example 5, let's take this example 5 and work on it. Try to read this on your own and see how much you understand. Everyone has read this question. Now, what is it asking? They're saying that consider the number 4 to the power n, okay, where n is some natural number. they want you to check whether for any value of n, is it possible that 4 to the power n will end with a 0? What do you think, guys? Is it possible 4 to the power n?
No, sir.
It's not possible. Why not? Because when you write 4 to the power n, this is basically, you know that 4 can be written as 2 square to the power n, which becomes 2 to the power 2n. Now, to get a 0, what do you need basically? You need a 10 as a factor, no? 10 should be a factor. And if
Should be
you
in the form of by power.
for a 10 to be a factor, 2 and 5 both should be the factor of that number. But here I'm seeing that there is only factor is 2. How many times 2 is there? 2n number of times. But only factor is 2. The 5 is not a factor over here. And I know that this number can be factorized only in this possible way. This is unique. Just now we learned fundamental theorem of arithmetics. If there is a number, it can be factorized as a product of prime numbers only in the unique way. This is the only way, 2 to the power 2n. Guys, just give me 1 minute. Okay, so have you people found out what is the HCF here? Question 6. HCF and LCM.
Yes, sir.
Yes, sir.
Yes, sir.
I don't know how to find HCF. Can anyone tell me how to find HCF? Anyone teach me how to find HCF of two numbers? Let's say this example, 6 and 20. How do I find the HCF of 6 and 20? Who can explain? Who can teach me? What? All of you found out.
Sir,
Yes, Kavya, go ahead.
like in prime factorization, sir.
Yes, so first step is we have to do prime factorization. Okay, so I did. These are 6, 3, 1, so let it be 2 into 3. So 6 can be factorized as 2 into 3.
2 into 3.
And then 20. How do I factorize 20? 10 times, 5 times, 5 times. This is basically 2 square into 5. So tell me, how do I find the HCF then?
Sir, taking the number which is common among both and the lowest power of that number.
Yes, we need to look for the common factor. Which is a common factor? Which is a common factor? Which is a prime number? Of course, everything is prime number here. So 2 is a common factor. 3 and 5, they are not common here. So we should not look at 3 or 5. Only 2 is common. So now, which one do I take? Do I take 2 or 2 to the power 2? I have to take the least power, right? Smallest power. So HCF will be actually only 2. Everyone got that?
Yes, sir.
And then how do I write the LCM? How do I find the LCM of the two?
Writing all the factors and their highest power.
Yes. So when you have to find the LCM, you write all the factors. So when I say all the factors means you look at the prime numbers. 2 is a prime number, so 2 is a factor. Write that. Then you see 3 over here. So write that 3 also. And then I see a 5 over here. So write that 5 also. Now look at the highest power of 2. What is the highest power of 2? It is 2 over here. So write that 2 to the power 2. 3, highest power is 1 only. So there is no need to write anything. 5 also, highest power is 1. So no need to write anything. So your LCM is 2 to the power 2 into 3 into 5. Which is how much?
60.
60. Okay. Everyone understands how to find the HCF and LCM? Quickly confirm, guys.
Yes, sir.
Yes, sir.
Yes, sir.
Anybody needs more clarification? I didn't hear from some people. All of you confirm quickly. Those who have already confirmed, it's okay. The rest of you who did not speak up.
Yes, sir.
Anushri, I didn't hear anything from you still. Are you clear with this?
Yes, sir.
Okay, fine. Now, there is an interesting fact which you need to learn about HCF LCM. Do you know this? HCF into LCM of any two numbers A into B, when you multiply them, multiply the HCF with LCM, you will get the same as the product of the two numbers. Let's try that over here. What was the HCF here? What I'm saying is HCF into LCM should be equal to A into B. My HCF, I got it over here is 2. LCM was how much?
60.
Yes, LCM was 60. And what are the two numbers? 6 and 20. So this, anyone will consider as A, anyone will consider as B. Now don't confuse with this AB with the one which we did in Euclid's division lemma. Okay, that was different. These are just two random numbers A and B, for which we are finding the HCF or LCM. Okay, so it should be 6 into 20. Now you see, this is also 120. This is also 120. So what does it tell you? That HCF of any two numbers A comma B multiplied to LCM of A comma B will be equal to the product of the two numbers A into B. So if everyone understands this.
Yes, sir. Yes, sir.
What to example 7, quickly finish it. Very, very easy question. Do that very, very fast. So find the HCF, then find the LCM. Not by prime factorization this time, use the formula. Just now we learned.
Sir, why should the formula, sir?
Say that again. Why?
Why should we use the formula, sir, to find the LCM? We can directly use the prime factors only.
Yes, you can. But sometimes the things will get cancelled and the process will become easier if you do using this method. So you need to learn this also, okay?
Yes, sir.
Here you are seeing the numbers are big and the HCF is very small number. So maybe it's not getting cancelled, but sometimes the number HCF can also be bigger and will cancel out few things. The calculation of LCM will become much easier, okay? Right, so let's do this problem. What is this example? 7, 96 and 404.
Completed, sir.
Tell me how to factorize this 96.
2, sir. 48 to 24 to 12.
So what should I write it as?
2 to the power 5 into 3 to the power 1, sir.
So you need to write 3 to the power 1. If you don't write any power, that itself means the power is 1. Okay. Yeah. So let's factorize the other guy also. 404. Anything else can we do?
101, sir.
So what should I write the factorization of 404 as?
2 square into 101.
2 square into 101. Now, what is the HCF of 96, 404?
2 square.
Only common factor which I see here is 2. 3 is not common, 101 is also not common. So I have to write 2 only. And what is the minimum power of 2? It is 2 to the power 2. So it becomes 4. Okay. So the HCF of this is 4. Now, we are not going to use the prime factorization to find the LCM this time. What we are going to use is the formula just now we learned. So just now we saw that HCF into LCM will be equal to A into B. So what should I write LCM as? I will send the HCF down to the denominator on the other side. So LCM of the number will be A into B by HCF. So this is how you will write it. And just write the numbers. A is 96, B is 404 divided by HCF, which is 4. So I think it is easier to cancel this one and you can write 96 into 101. Like this, what do you get? 96, 96. Was it easier or not?
Yes, sir.
So we can write that LCM of 96, 404 is 9696. Okay, everyone is clear with this now? How to find the LCM, how to find the HCF, and also the formula. All the 3 things just now we learned. Right. Move on to the example 8. Now, this time we have 3 numbers, not just 2. So find the HCF and LCM using the prime factorization method. All of you try to do this on your own. Only if you need help, then you look at my calculation. I will just write it for you. Verify. Okay. Okay. So we have done the factorization of all the 3. So what is HCF here?
Yep. 2 into 3, 6, sir.
Okay, so 2 is a common factor, and along with that 3 is also a common factor in all the 3 of them, right? So we have to take
Completed,
both.
sir.
Okay, very good. So 2 and 3, both we need to consider. 5 is not considered because 5 is not there in other 2. So 5 is not a common factor. So we considered only 2 and 3, but we have to take the minimum power of 2. What is that? In both the cases, the minimum power is 2 to the power 1 and 3 to the power 1. So write it as 2 into 3, which is 6. Is that correct? Is that what everyone is getting?
Yes, sir.
Now, LCM. So LCM, what do we do? What is LCM? You people got, tell me.
2 cube into 365. 3600.
3600.
Sorry, sir. 360.
Uh-huh.
360.
Charan, your audio keeps breaking. I think your network is not good. Maybe you can type in the chat window your answer. Other people, tell me, what is your answer you got?
360.
360. Okay. Thanks. Charan also got 360. So what do we do basically? When we are writing the LCM, we take all the prime factors, all the unique factors like 2, 3, and 5. These are the only 3 factors, right? 2, 3, and 5. And what do? We take the highest power of all these 3. So what is the highest power of 2 over here? 3, right? Highest power of 3 is 2, and 5 it is 1. So this is basically 8, 9, 5. Is that right? So 8 5s are 40, and 40 into 9 will be 360. So looks like everyone is correct. Only I did not know how to do this. Okay. This seems like a very easy thing, right? Not much to it. So you should be able to complete this exercise 1.2 also very, very fast. Yeah. So since you do not have school, I would recommend that you complete question number 1, 2, 3, and 4. At least these 4 questions in home by tomorrow. Okay. This is your homework assignment.